So welcome to another lecture. In this lecture again we'll be doing a JEE problem. Beautiful problem. You'll learn a lot while doing this question. Before you start attempting the question, what I'll suggest is in the comment section you will get 2 or 3 PDFs. So the first PDF that you will get is key concepts to master first. So this is the PDF. What I have tried to do is I have uh, listed all the formulas that you will be required when you are doing this problem. So please have a look at this. There might be few things that you may not understand. So it will help you if you can refresh your core concepts. The second PDF that you will be getting is this PDF. Whole of the problem has been solved, and the notes are there in the PDF. So please have a look at this, because uh, looking at these videos will help you understand the kind of concepts that you will be using uh, when solving the problem. Because this lecture is about half an hour long, you will have to patiently work through the problem. There is a lot of maths involved. Of course, physics is there, but lot of raw maths is there. So I hope you enjoy the lecture. I hope you learn a lot, and let's start. So let's try to understand the question first. Two non-viscous, incompressible, immiscible liquids of densities rho and 1.5 rho are poured into the two limbs of a circular tube of radius r, and small cross-section kept fixed in vertical plane as shown in the figure. So these are the two liquids which are given. The properties are given and the densities are also given. So they have densities rho and 1.5 rho. So these are the densities of the liquid. Okay. Now each liquid occupies 1/4 the circumference of the tube. So each liquid occupies 1/4, which implies that uh, the two liquids will occupy half the circumference of the tube. So that is why you see this, you see this line. So this is 1/4 of the circumference. This is 1/4 of the circumference. Consequently, what you need to understand is, because they are covering half the circumference of the tube, they are covering 180 degree. So each of the liquid is covering 90 degree. So this part, this whole part, so this liquid will be covering 90 degree, and this whole would be 90 degree. We need to understand the geometry of the question first. Okay, so we are okay till here. Find the angle theta. So this is the angle theta to the interface makes with the vertical in equilibrium position. Find the angle theta that the radius of the interface. So this is the interface. Interface implies where the two liquids are, touching each other. See, these are immiscible liquids, so they won't dissolve into each other. So that we should be clear. So now what do we want? What we want is that, what is this? What is the angle that this interface will be making with the vertical in equilibrium position? So radius to the interface makes, so this is the angle that we need to understand. And then of course we'll first calculate the theta, but once we say, let us assume that we have calculated the theta, what is else that they want? If the whole liquid column is given a small displacement from its equilibrium position, see, there's a small displacement that would be given. And what we have been discussing in the series of this lectures is that if it's a small displacement, so for example, let us assume that the displacement would be phi. So we understand that sin phi would be equal to phi, and we also understand that cos phi would be equal to 1. So because these are small displacements, so if we give a small displacement phi, show that the resulting oscillations are simple harmonic. So you will have to discuss that, will have to show that the resulting oscillation is a simple harmonic. Okay, This 2 is done. So B part 1 is this should be SHM, and second is find the time period of these oscillations. If you have been following this playlist before, in the questions before I have done, we calculated frequency, and now they are asking for time period. It doesn't matter much because frequency is 1 upon time period. So anything that they are asking, we can understand. So this is about the question, and step by step we'll start going through the question. So let's start. One thing that I'll reiterate that, see, this angle, this whole of this angle, you need to understand this well. This liquid, say liquid X, this would be subtending an angle of 90 degree at the center, and this liquid, say Y, would be subtending an angle of 90 degree at the center. So this is our this is our setup. Now let's start doing the question. So I have done the question. I'll be sharing the PDF also. You can see this small circle. This small circle that I have drawn is very critical to us. Please see, it will help if you can draw the diagram on your own. So then you'll understand more about the situation. So let me explain the situation. So what is happening is we'll use the funda of center of mass. I'll make some space here and I'll try to explain it here. We'll use the funda of center of mass. Center of mass. What that center of mass funda will imply is that this liquid, the center of mass would be somewhere here. So this is not an approximate. This would be in the middle of this arc. So if whole of this arc, this liquid arc is subtending 90 degree, this center of mass, let me call this point, what I have called it here, I'll use the same. So let me call this B. This is point B. This B would be center of this arc. So it will be subtending an angle of 45 degree here. I hope you are able to understand what I have said. If not, then let me try to explain to you again using this liquid. Now I have called the center of this to be A. So this liquid, let the center be A. Center of mass be A. So this angle BOZ, I have said that this angle is equal to 45 degree, where B is the point where center of mass of this liquid is there. So similarly, point A is the location where center of mass of this whole liquid is there, and I have marked it A, and angle AOZ, this angle would be equal to 45 degree. See, the full liquid, this full liquid is suspending an angle of 90 degree at the center. So half of the liquid where the center of mass is at B would be suspending an angle of 45 degree. Similarly, for this liquid, if the full liquid is suspending an angle of 90 degree at the center, so half of the liquid, this AOZ, would be equal to 45 degree. Hope this is making sense. This is what I have mentioned here also, so that there is no confusion. Okay, now I'll rub this for a while because there is another thing that I want to make clear, is that if whole of this AOZ is 45 degree, then this angle this implies that angle AOY would be equal to, see, if this whole is 45 degree, so this angle would be equal to 45 degree minus theta. So this is equal to 45 degree minus theta. Okay, great. Now if this whole is 45 degree, what this implies is that angle BOY, if BOZ is 45 degree, therefore BOY, angle BOY would be equal to 45 plus theta, 45 degree plus theta. Let me write it here also. So what I'm trying to tell you is, and why am I doing this? Because I'll require this in 2 minutes. See, this whole of this angle BOY, this whole angle is 45 plus theta, and AOY, this angle is 45 minus theta. Now you understand about center of mass. The basic, a very simple definition of center of mass is that you can replace the body with a point having the mass equal to whole of the body. So for example, what I'm trying to tell you is that I can replace whole of this liquid. I can replace whole of this liquid by a point at B which will be having the mass equal to whole of this liquid. That is the definition of center of mass. Now I can replace whole of this liquid by a point at A which will have the whole mass equal to the to this liquid. Let me mark it here again. So whole of this liquid, the liquid which was here, has been replaced by a point at A which has the same mass at this. Similarly, whole of the mass of this liquid has been replaced by a point at B which has the same mass as whole of this liquid. Now I hope this would be making sense, and let me show you the previous diagram again. Now see, what we will be doing is that we will be uh, the mass will be in this direction. Here also the mass would be in this direction. Now due to these two masses, so the mass at A will be trying to push the liquid in the anti-clockwise direction about this pivot A. This would be the pivot A, and B liquid would be trying to push in the clockwise direction about the pivot A. The perpendicular distance would be equal to this, and for point B would be equal to this. So what, to calculate the torque, what we will be required to do is multiply this weight by this distance, and for this multiply this weight by this distance. I hope this is making sense. So once it is in equilibrium, when it is in equilibrium, that is where we will calculate this angle theta. So when it is in equilibrium, what it implies is that the torque in the anti-clockwise direction due to this liquid is equal to the torque in the clockwise direction due to the liquid B, and the torque would be calculated about point A, and we will have to calculate this distance when we are calculating this torque, and we will have to calculate this distance when we are calculating this torque. And this is what I have done here. Now let me show you this figure, and now things will start making sense. Again, I'll spend 2 minutes to just explain the geometry so that you don't face any difficulty. So this point A is my center of mass, this is my weight m1g. I need AC to calculate my torque. B is my center of mass, this is my weight m2g, and I need to calculate BC. Hope this is making sense. Now I consider triangle OAC. Triangle OAC. See, perpendicular upon hypotenuse. Hypotenuse is the circle, which is radius of the circle, which is r, is equal to sine 45 minus theta. We have 45 minus theta. We have calculated here that this was 45 minus theta. Basically, we are considering this. We are considering this triangle. This triangle. So this angle is 45 minus theta, which is written which is written here. So AC would be equal to R sine 45 minus theta. Hope this is clear. Then I take this triangle ODB. In this figure, this triangle is this one. This one. So triangle ODB, here perpendicular upon hypotenuse R is sine 45 plus theta, and therefore DB is equal to sine 45 plus theta. So I have calculated AC. This is what I have calculated. For calculating the torque, I will multiply this distance by this weight. Similarly, here I will calculate this weight by this distance dB, where dB is sine 45 plus theta. Now, in the equilibrium position, both of these would be balancing each other, and that is what I have written here, that at the equilibrium position, this M2G, M1G R sine 45 minus theta will be equal to M2G R sine 45 plus theta. So, the torque at AC, this torque, which is in the anti-clockwise direction, is balancing this torque M2G, which is in the clockwise direction. This is in the clockwise direction, this is in the anti-clockwise direction, and when they are in equilibrium, they balance each other. So they will balance each other. So basically, I can write this as M1G R sine 45 minus theta would be equal to M2G R sine 45 plus theta. Now, if you see, this GR will cancel, and my M1 upon M2, my M1 upon M2 would be equal to sine 45 plus theta upon sine 45 minus theta. 45 plus theta upon 45 minus theta, M1 upon M2. And in terms of densities, because I have been given density, what I can write is 1.5 rho into the volume. The volumes are the same. And multiplied by rho v, because the volumes of both the liquid are same. They are suspending the same 90° at the center. So the volumes are same. So these densities were given. So this is 3 by 2. 3 by 2 will be equal to M1 upon M2. So my M1 upon M2 is equal to 3 by 2, which is equal to sine 45 plus theta upon sine 45 minus theta. Now I have to solve this equation for theta, and what I have done is, I have used a small trick. What I have done is, I have replaced sine 45 plus cos theta by A, cos 45 sine theta by B. I have put this as A plus B upon A minus B, 3 by 2. Then I have used the componendo dividendo method to calculate A and B. Once I have calculated the ratio of A and B, then I understand, I replace A by sine 45 cos theta, and B by cos 45 sine theta. So I have replaced these, and consequently my tan theta is equal to 1 by 5, and theta is equal to tan inverse 1 by 5. So this is my equilibrium angle, this theta. Now let me replace all this. So after doing all this, what I have arrived at is that my theta is equal to tan inverse 1 by 5. My theta is equal to tan inverse 1 by 5. So I have done my first part, and now I'll move to the second part. So in the second part, what happens is that we slightly displace the liquids by 5 in the anti-clockwise direction. Basically, we push the liquids in the anti-clockwise direction by 5. Now consequently, the angles will also change. So basically, in this diagram, once I have moved the liquids in the anti-clockwise direction phi, these angles, this theta plus 45 and 45 minus theta will also change. So I have copied this here. So this is the setup that we had. So this 45 plus theta will increase by phi. Why? Because the liquid on the right side, this liquid, this will rise up by phi. Say this will rise up by phi, and this part will also rise up by phi. Once this rises up by 5, so this angle 45 minus theta, this 45 minus theta, this will decrease. 45 plus theta will increase by 5 and 45 minus theta will decrease by 5. Why? Because this will become closer. A will be closer to C now. So that is why this 45 minus theta will decrease by 5. So that is what I have written here. This 45 minus theta will decrease by 5 and 45 plus theta will increase by 5. Hope this is making sense. So now what the situation that we have is that M2G, the angle suspended would be 45 plus theta plus phi, and M1G would be suspending an angle of 45 minus theta minus phi. And when we have to calculate the torque, so see the basic concept remains the same thing, but M1G is being multiplied by R sine 45 minus theta minus 5 now this angle, and M2G is being multiplied by R sine 45 theta plus phi. So not a very big change, you just have to change these angles. Basically you are just working with, rest of the funda will remain the same. All that you need to do is change this 45 minus theta, change this 45 plus theta. This 45 plus theta is getting replaced by 45 plus theta plus 5, and 45 minus theta is getting replaced by 45 minus theta minus 5, because this angle 45 minus theta is being decreased by 5, because this will move towards this will move towards this. So now I have to replace this M1 by 1.5 rho V, this M2 by rho V multiplied by G. So now I have to do the manipulation, the mathematical manipulation for calculating the new torque. This is the new torque which will be there. So I should be mentioning this as tau dash. This is the new tau. This will give us the SHM equation which they had asked us to show. So now a lot of mathematical manipulation is required, and I hope you will be able to do the mathematics part. Anyways, I'll be this PDF would be part of the comment section. Please have a look at the PDF. If there is any doubt, please mention in the comment section. I'll be glad to help you out. But let's go through the mathematics part. So now rho G VR is common, and I have 1.5 sine, and this is the expression that I have. So now what I have done is expansion of this sine 45 minus theta minus 5 and expansion of this. So you will have to patiently work through the expansion. So this is 1.5 sine, this is sine A cos B minus cos A sine B, this minus 45 plus theta plus phi. Again this is expansion of sine A plus B, this is expansion of sine A minus B. Basically this is expansion of sine A minus B, this is the expansion of sine A plus B. So that is what I was saying, that now going forward, patiently you'll have to look at the you'll have to work out the mathematics, and if you have any doubt, please refer to the PDF. So it will be a help. And now the small angle approximation, I'll replace this cos phi by 1, I'll replace this sin phi by phi, I'll replace this cos phi by 1, I'll replace this sin phi by 5. I have a separate lecture about small angle approximation. You can have a look at that also. This 1.5 sine 45 minus theta. See, this cos phi has been replaced by 1. 1.5 sine cos 45 minus theta. This sine phi has been replaced by 5. Minus sine 45 plus theta. This cos phi has been replaced by 1. And this sine phi has been replaced by this phi. And this rho g VR and the rho g VR is here. And now you'll have to again understand bit mathematics again. See, what you need to understand is that this part and this part, I have done the working, so don't worry. See, this part, whole of this part is equal to 0. I have done the working here, so don't worry, I have done the working here. You can look at the working. This part is equal to 0. So I just have to focus on this part. I just have to focus on this part, minus cos 45 minus theta phi minus cos this. And if you look at this, the phi is being taken out. This part is there, and there is a minus here, and rho g VR is there. Now, if you understand this well, if you have done questions like this before, you will understand that now slowly we are reaching the point where we will be able to show that this is a SHM. Basically, we'll be able to write this as tau is equal to minus k phi. Slowly we are moving towards this. But before that, I have to calculate this, which again is a mathematical part. Let me show you that mathematical part. I won't be going into the detail. Cos 45 plus theta, cos 45 plus theta, plus 1.5 cos 45 minus theta, plus 1.5 cos 45 minus theta. So I'll work this out. And I've done the working. You can look at the working. This whole of this is a working, and finally this is equal to root 13 by 2. So this is equal to, this is equal to root 13 by 2. So that is why this whole of this torque, tau, can be written as minus rho g VR multiplied by root 13 by 2 phi. And so this is basically tau is equal to minus k phi. And that is what we have shown, that the whole liquid, when it is given a small displacement, the resulting oscillation is a SHM. So we have reached till here. We have shown that this is basically, this is a SHM, and now we have to calculate the frequency time period. So let's move ahead. I understand that a lot of mathematics is there, but that is how these questions are, and you'll have to manage. So now that I have reached this point where I have written the the restoring torque in terms of some constant multiplied by phi. Now what I need is I need to calculate the frequency. But there is a issue that I am facing. The issue that I am facing in that is that I have this volume term here, and directly I can't jump to calculating the omega, the phi, because this volume is unknown. So somehow I need to take care of this V. So what I do is I'll show you in brief the next steps that I'll be doing. So this is where I've reached till now. Tau is equal to minus k phi. I know that I can also write my tau in terms of moment of inertia, where I is the moment of inertia. So this can be written as I d square phi by dt square in terms of the moment of inertia for angular motion. Now, what we have is, if you look at the diagram that we have replaced the whole of the liquid by a mass m, which is at a distance r from the pivot. Now, if I have to calculate this moment of inertia about this pivot, so I would be equal to mr square, and I have two masses. This is mass m1, this is mass m2. So I'll be calculating the moment of inertia of the full system. and then then what I'll be doing is I'll be comparing this equation with this equation. So let me show what I will be doing. So the first thing that I need to take care, this is the tau, this is the restoring force that I have arrived at, minus rho g VR root 13 upon 2 phi. This is what I have arrived till now. Now I'll write my restoring torque in terms of moment of inertia, d square phi by dt square, and this is what I was saying, that the moment of inertia of the system can be written as mr square plus m2 r square. This is for the two liquids, and when I put this m1 in terms of the density to volume, this is the 2.5 rho v r square is the moment of inertia that I get. Now this moment of inertia I'll put here. This is what I have done here, d square phi by dt square. I have compared this with minus rho g VR root 13 by 2 phi. Now this is where the magic will happen. There will be a lot of cancellation. Rho will get cancelled, V will get cancelled, R will get cancelled, rho will get cancelled, V is gone, R is gone, and finally I have d square phi by dt square is equal to minus g root 13 pi far by phi. This 2.5 will get multiplied by this 2, and that is why you see a phi here. Now this d square phi by dt square, now this I can compare this with the d square phi by dt square is equal to minus omega square phi. This is what I get from my SHM, because I have proved this is my SHM. So this portion, let me highlight this. So this portion is equal to omega square. So this is what I have done here. This is what I have done here, that this omega, sorry, this omega, sorry, this omega is equal to g root 13 by 5r square root, because I'll be comparing these two, na, omega square is equal to g, so it will be a square root, and this omega is equal to 2 pi f is equal to 2 pi f. So I calculate the value of frequency as 1 upon 2 pi g root 13 by 5r, and consequently my time period would be equal to 2 pi 5r upon root 13 g. So this is what is my final answer. This is what is my final answer. So I hope you enjoyed this. This was a pretty lot of physics and maths was involved. You will find the copy of the PDF in the comment section. In case there is any doubt, please let me know. I'll be glad to address your doubts, and it's a good question. You can learn a lot from it, and I hope you enjoyed it, and best of luck for your exams and rest of your career. Thanks a lot.